Okay, so I think the recording is in progress. Everyone can see it. So I'm going to start off. So this is the second episode, if I can say, of our office hours for KubeSlice. And, I'm Divya. And I am one of the people who works closely with the KubeSlice project. I help out in a bunch of stuff. But today it's not about me. Um, and we're gonna talk to Prabhu, who's on the call today, and he's gonna walk us through KubeSlice live, I guess. So that's gonna be a lot more exciting than me, talking about myself. So Prabhu, I would rather you introduce yourself because you've got such a breadth of experience. I think it'll probably take me more time to introduce you, and I probably will not do as much of justice as you could. So why don't you go ahead and introduce yourself?
Hey everyone, thanks for joining the call. My name is Prabhu Navali, Director of Engineering here at Avisha, the co-founder along with Prasad and Raj. For the last year and a half, we have built the KubeSlice, and part of that we just open sourced. We call it as a KubeSlice Open Core, and happy to be here to talk about it.
And we also have Prasad here, who actually doesn't need an introduction. But Prasad, do you want to actually go and introduce yourself once more? Because you were there on the last office hours. So you want to go ahead and introduce yourself?
Well, I am Prasad. I have the pleasure of working with Divya and Avnish. I'm going to talk to you tomorrow, or I don't remember the schedule, but it's in my calendar. So I think we are excited about KubeSlice. One of the foundational things is after we have done implementation in different SaaS operations and stuff like that, Kubernetes is growing. And there are lots of fundamental things which need to be done for production deployments, which have say I used to run a large SaaS operation. A team started with saying that, hey, I want to have a cluster. I said, okay, go ahead. My team would give them a cluster, and they would experiment something, and then it has a life of its own, so it actually goes into production. Then we kind of put all the scaffolding with respect to operational tools and visibility and all that stuff. The next team comes over and says, hey, I want to experiment something because I want to also modernize my workloads. And they bring it in. So they say, oh, I'm going to do some cluster for myself. And what happened is that they don't want to disturb other people, so we ended up giving them cluster. Likewise, like 2 or 3 or 4 people teams would come up and then say they build their own clusters. Then we had a huge cluster sprawl, right? So that would increase the operational headache. My team would kind of constantly put scaffolding for every cluster, and then kind of build dashboards. There are hundreds of these dashboards, right? Then it became a nightmare for us to operate it. And cost was increasing because the control plane is not cheap, right? And then when you have a cluster, how many number of resources there are, they're kind of not optimized. So we were always thinking, how do I create a tenancy? So that inside a cluster, you can kind of create tenancy and then give individual teams a tenant so that they can play in that workload, and then have isolation defined such a way that no team can fight for resources, or no team is impending on somebody else's resources. So we thought through that and then said, okay, that is when this Avisha came about. And then we built all the operational challenges, and as well as the primitives which are there in Kubernetes defining the tenancy. And then, well, since it is a SaaS operation, we always used to have, hey, I want to have a cluster closer to my customer. So that would mean I would have to deploy it in not just in one centralized place, but in different edges and different places. So how do you connect those clusters together? and then still maintain the tenancy. Those are the foundational aspects which we thought are important for a free enterprise. That is what KubeSlice is, right? So that the genesis behind that is that.
Right. And Prabhu, I am really excited to see what is in the demo today. So do you want to go ahead and give a brief of what you're going to show us today, and then maybe walk us through it, because I'm sure a lot of us here, including myself, are really excited to see this. So yeah, the floor is yours.
Just unmute myself first. Let me share my screen quickly. We can go over a few slides, and then I'm going to keep the. Okay, so yeah. Let me know if you can see my screen.
Not yet.
Not yet.
Now, yes.
Okay. So we're going to be going back and forth between the couple of slides I have and then the shell. Where I'll be running a shell script, but at the same time we'll be stopping in between to look under the hood, what's going on. So without much delay, so I want to just give a quick overview of what application slices are, right? So as Prasad alluded, it's a way to create a larger workspace across multiple clusters and specific to set of applications. So each application slice can span a single cluster or multiple cluster with a inbuilt overlay network onto which you can associate namespaces and the applications, right? So that will be one of the core component for the multi-tenancy that we talk about, right? So I'm going to focus mostly on the open core, what's in the open core, the open source. One of the quickly, some of the core components, some of them we will touch them on today's demo. As you can see, there are quite a few different deployment options are there. Different features are available in the open core, and we will touch upon some of the major ones in the demo today, and maybe follow on demo we can show additional feature workflows, right? So the main core components or core features to build the multi-tenant slices that we are talking about in this picture here are the basic one is the multi-cluster connectivity, right? So you can have clusters as clusters are sprawled all over the place. You can have clusters in the EKS, GKE, multi-cloud, on-prem. They are connected with an overlay network to provide part-to-part connectivity, right? So that is one of the core feature of the KubeSlice. So a lot of this is automated, right? The automation of the gateways, the slice routers, the IPAN, connectivity between full cluster, full mesh connectivity across the clusters, the routing, part-to-part connectivity. That is one of the main features. Once you have a slices up, right, so you can have namespace association with the slices. So it's like you can deploy, for example, 5 clusters, 100 slices, right? So each slice can bring in its own set of namespaces. And within the namespace, you can have multiple applications. And one thing that one thing that is unique is it doesn't have to be HTTP application. It can be like a TCP application, UDP application, or any IP application, right? So the namespaces are associated with the slice, right? So we have 2 constructs there: application namespaces and allowed namespaces. We can talk about it a little bit more on that later on. And then we have application onboarding on the slice. Basically, if you have a namespace associated with the slice and any deployment of an application in that namespace will be automatically onboarded onto the slice, right? So that means what, right? So that means they can have a connectivity across the slice. So anywhere, for example, an application here onboarded on the slice would have connectivity with an application that is like, the service that is running here. So of course, there is how do they do that, right? So we do that using service discovery, right? So there is a service discovery at the basic level without even the service mesh, right? So a service can be exported, native Kubernetes native service is exported and then imported so that they have an access over the overlay network. So when I say overlay network, that is a different L3 IP domain with the service associated with it, right? So this gives us a service discovery across the slice, across different workloads. So in addition to that, I think we have on a slice, for a given slice, we can associate network policies. So those network policies will be applied to all the namespaces in all the clusters that slice is associated. Not only we normalize the network policy across the slice, we also monitor them. So if there are any conflict drifts, there are alerts, events that are generated for the drifts. In addition to that, we have Istio service mesh integration. So what does it mean is if we have Istio deployed on the and the Istio is deployed with the control plane, each cluster having a separate control plane, and the services are exported from one cluster onto the other cluster, and the services will be imported onto virtual service on each sidecar, or on an ingress gateway or an egress gateway. So you can deploy even with the Istio, with the Istio service mesh, and then the integrating that with the KubeSlice service discovery. Other than that, I think we have a controller, which is where you can create multiple tenants, basically multiple projects, and associate each tenant with the project, and each project can have multiple slices, and you can provide tenancy at the slice level or at the project level, right? So these are some of the open core features, and I think I kind of touched upon the deployment options. As I said, there are a number of different ways you can deploy the KubeSlice. Basically, starting with the multi-cloud on-prem connectivity with the different slices, with different workload types, HTTP, TCP, UDP, any IP-based workloads, right? And then you can deploy with the service mesh, right? When you deploy with the service mesh, you can deploy with the ingress-egress gateways for east-west, right? So, and then we have multiple projects. So I think I know I have about 40 minutes of demo, so I should get going. So quickly, what we're going to do today is to show all the inner workings of the KubeSlice, right? So what is the slice made up of, and how do you deploy a slice, and how do you onboard an application, HyperF application, and a booking for application, and how do you show the connectivity service export and import, between the clusters. So as I said, this can be done across many clusters, not just 2 clusters. It can be 3 clusters, 5 clusters, but I'm going to do this getting started with the kind. So it's going to show the kind clusters. And then we are going to walk through this demo steps, right? So while I want to walk through this, I'm going to start off it's like a shell script with the stops along the way. So we'll just get started.
So, Prabhu, can you increase the size?
Yeah, that is what I was going to say. I'm having a lot of trouble peering, and I'm sure
you can't see the slide, or you can't see the
command prompt. Both of them actually. The command prompt needs to be visible. So I think increasing the font there would help, or maybe maximizing the window also.
Okay, that's better.
Yeah, that's perfect.
Maximize the window so that it covers the entire screen.
Yeah. So okay. So I have to go back and forth. So we will start running the script, and it will stop at certain places, so we can go look at what's going on under the hood. And then I have another window here where we can see whatever we want to see as well. So let me just increase the font on this. So this is visible though, right, Prasad?
Yeah.
Yeah. Okay. So the steps are right, what we show in this demo is basically we go back to this slide here. So this is all done on the Windows with the WSL Ubuntu with the kind clusters, right? For now, right, for this demo, right? So we will have three clusters: controller cluster, which is going to be the host of the KubeSlice controller, which is where most of the configuration is deployed, right? The slice configuration, any slice related configuration is deployed on the KubeSlice controller. And the worker clusters are where the slices are orchestrated. Basically, we have a controller which is as I said, is the gatekeeper for all the configuration. And each worker cluster, we have several components, right? So what I don't show here the nodes per se, but if you go back and look at it, the actual one of the deployment here where we have multiple nodes, one of the node can be specified as the gateway node. We prefer people put a gateway node label on Avesha label on one of the gateway node where it would all the gateway related components, right? All the KubeSlice components are deployed on that node, right? So if you go back here, okay, so go back to the kind. In the kind today, I have only one node, mainly due to the memory issues. So we will deploy both applications and the gateway components or the slice components on the same node, right? So what are the components, right? So let me see here what's going on. Okay, still creating the clusters. It's creating the worker cluster, and as I was saying, it will create the kind controller and kind worker clusters. I think we are in the step one right now, right? So while that is going on, we can go back to here. So we are going to deploy the controller on the controller cluster. Then we will deploy the what we call as the slice KubeSlice operator, which is the operator with many controllers built into it, manages the life cycle of the slices. Right. So we will deploy the slice operators. Then we will deploy the slice. Actually, before we register, we deploy the slice, we register these clusters with the controller. And then we will work on creating the slice convoy. And we'll deploy it on the controller cluster, but then it will be orchestrated on all the worker clusters. So we'll dig deep into that, and then what are the components that are happening in that one. Then we'll deploy the iPerf on the slice server and the clients, and then we'll we'll check the connectivity across the clusters. So even though they are kind, they are internally connected through the open VPN channels, right? So as we go back here, each slice has a slice VPN gateway that is open VPN client server pay, and that will enable us to connect the clusters. So for every cluster you add to the slice, we will build a full mesh of VPN channels. That VPN channel is on a slice subnet, right? So each slice is associated, has its own slice subnet. You can view the slice as private VPC across many clusters, right? So it's its own VPC with its own slice subnet. So the IPAM for the slice is done by the controller. So the slice will have its own subnet, and then every cluster part of that, right? So every slice part of in the cluster will get a piece of that subnet. So That part of the IPAM is done by the controller. And within the each cluster, the IPAM is done by the slice router. So the overlay network is basically built at the VPN and the slice router with all the VXLAN channels in between here, and then the open VPN channel between the clusters. So let me see here where we are. Looks like, okay, we are at the point where we can deploy the control. So what we have done so far is, like, we did the worker and the controller clusters, and then we do use Cert Manager to deploy some certificates for the webhook. This can be as one of the enhancements we want to do in the open source, remove the dependency on the Cert Manager, but for now, we use Cert Manager to do that. So then at this point, we're going to deploy the controller, basic configuration. There's not much here. So what is the endpoint, and then what is that, what's the back? And let's see here. Okay. So while the controller is coming up, we can go back here and talk a little bit more about what else I want to talk about. Yeah, so I was just talking about the overlay network, right? So the overlay network is built. It's like you can look at it as a bunch of tunnels that are interconnected through the slice router, right? So that will give you the overlay network, and any application that is onboarded on the slice will get an extra interface. So that is the network service mesh interface. So we do use an open source component called network service mesh, which is kind of inspired out of it's a development. It's an open source project. You can look it up, NSM network service mesh. It is kind of similar to what Istio does for the services. NSM does that for the network services. So if you look at it, these VPN gateways, slice router, these are all network service components, and we use the NSM to tie in, build this overlay network using the NSM construct. So one of the good thing about it is it simplifies the automation of all the connectivity. So think about it. To orchestrate this manually, it would probably take for a long time for somebody to do it. So for across multiple clusters, across all the building the overlay network, is a significant amount of automation that goes in to get that happen, right? So, and that NSM definitely helps, for the connectivity, especially we use that for the inter-domain single cluster connectivity. And then for inter-domain, we use the OpenVPN for now, but it can be extended with the NSM inter-domain as well. So going back to here, looks like we are moving ahead. So at this point, I think we were trying to see what we are doing here. So KubeSlice controller, yeah, it's getting deployed, and we'll wait for the controller manager. I think I didn't hit run here. My bad. But we'll wait for that. So meanwhile, we can talk a little bit about because we are deploying controller, we can talk a little bit about controller, right? So, so controller is, in our case, the controller is actually an extension of the Kubernetes control plane, right? So most of the objects, slice-related objects, are CRDs, and any state and stat, spec and all that stuff is maintained through a number of CRDs. There are CRDs, that are specific to the controller. There are CRDs that are specific to the worker. So the worker operator is listening to the CRDs basically, right? So the changes in there's going to be a watcher basically watching for the changes in the configuration. So the controller has its own API that I think it's the KubeSlice controller API group, which provides an API group. And also there is an API group that is used to communicate with the slice operator. So those API groups are used to update the any of the configuration, like for example, slice configuration or slice status from the operator will be updated to the controller. That is done through those API groups and APIs. Right. So going back to here, it looks like okay. So we have done the at this point we should have the controller up and running. Okay, so we are ready for the cluster registration, but I will just show here it is running on the controller, right? So as I said, like Cert Manager is used to just to generate webhook certificate, and from the KubeSlice we have just a controller running at this point, right? So at this point we are ready to register the worker clusters. So we have 2 worker clusters, so we're going to go ahead and register them. So worker 1 is registered, and worker 2 is registered. So you can see worker 1 and worker 2 are registered at this point. So this is ready for us to go deploy the worker basically. So if we go back to the step here, we are ready to deploy the KubeSlice worker operator on worker clusters. So in order for us to deploy worker operator on worker 1 and worker 2 clusters, we need some data, right? So this is the configuration file, and one of them is the controller data. So what is the controller that we are talking to? What is the endpoint? What is the namespace, project namespace, and then what is the secret to talk about? So this is gleaned by you can there are steps in the documentation how to get the secrets from the worker. From the controller to deploy the worker. So we are here deploying the controller, operator on the worker 1. So while we are waiting for the the pods to come up here, so right now what we are doing is deploying the worker operator on the kind cluster, worker 1 and worker 2. So this will deploy the KubeSlice operator, which is the main workhorse for the managing the lifecycle of the slices, and also the network service mesh, the core components of the network service mesh. And we also use, I think there is another component here which we have talked about, which is the KubeSlice core DNS. So for us to do the service discovery across the slice, we maintain all the service endpoints on a separate core DNS component, it's called mesh DNS or KubeSlice DNS, slice DNS. People call them in different terms, but it's like an instance of the core DNS which will host all the the slice. The services that are on the slice. So when I say service on a slice, service endpoint on a slice, that service endpoint on the slice will have an NSN IP address, not the CNI IP address. So one other thing that I didn't talk about, I think we'll come back to that in a minute, but looks like we have the worker 1 registered. So we'll just, worker 2. Worker 1 should be done, but I think we're doing the worker 2. So we'll go back and look at the worker 1. Maybe it's coming up here. It's okay. This is still working on. So this one is running, this is the worker one cluster with the KubeSlice deployed, right? So these are all the basic components here. So some of them are NSM related, right? Admission hook, and the forwarder, manager, and the webhook, and the prefix service. And here's the KubeSlice operator, which is the operator with many controllers and also communicates with the KubeSlice controller to get the configuration and also post all the updates, right? And we also have NetApp pod here, which is for any network operations. We can get into that on another demo where we can show some of the prioritization across the slices. So you can have QoS associated with the slice, and then you can prioritize traffic across the slice on a given network gateway node. And some of that work is done by the network. And also, as I was saying, like there is a KubeSlice DNS. That is another one. Let's see if where we are with one. Okay. No. Okay, so it's going to apply so right now what we're doing is creating this slice. So we had to switch context to controller and then create the slice. If you look at the slice YAML, it has a few things here, right? So one of them is about the slice subnet, which is the subnet that the entire slice is going to be. Like using that, that's the slice subnet for the entire slice. Every cluster will get a piece of that, and that IPAM is done by the backend, right? And we also have slice type, which is application, and then the gateway types are OpenVPN, and the slice IPAM type is like in a local, because the slice router will do the IPAM for the local clusters. So in addition to that, these are the clusters that are associated with the slice. There is a QoS profile that you can attach to the slice. Again, like I was saying, we can go over this on another call. We use like hierarchical token bucket for the bandwidth control, and then there is a prioritization and DSP marking that you can do on all the tunnel traffic that is going out between the tunnels, right? So that is done by the NetApp pod and also this QoS pack. Other important thing that we want to talk about is the association of the namespaces with this slice, right? So you can associate, in this case, as you can see, application namespace, we have two different namespaces that are associated with it, right? So iPerf and the book info. So we'll show both the application deployment. And isolation is disabled for now, but you can enable. When you enable the isolation, appropriate network policies are applied to the namespaces, and then the monitoring of those network policies will happen. And then we also have what we call the allowed namespaces. This is critical because when you have isolation enabled, we kind of shut down all the communication from the external world. Basically, one way you can enable somebody talk to this is to adding them, giving them an exception, saying okay, Cube system, Istio system, Prometheus, or Grafana, or whatever, namespaces that you want to allow them to talk to the slice. So other than that, there is quite a bit of a thing that is specific to the Istio. So if you enable Istio and if you want to enable ingress and egress, that is there. So let's apply the okay, the slice is already created, and then we are applying the iPerf sleep. Okay, so I wanted to show the iPerf slice. Okay, so sorry, Convoy slice. So we deployed the Convoy slice. So as a part of deploying the Convoy slice, you can see there is a gateway associated with this. This is the OpenVPN gateway. And also there will something which showed up new is the slice router. So for every slice, you will have a slice router, which is kind of glue for all the overlay network. And also we have a tunnel between worker 2 and worker 1, right? So at this point, we have a slice deployed, we have the gateways deployed, we have the routers deployed, and at this point, we are ready to deploy the iPerf application. So if you look at this one, it doesn't have anything other than a deployment. Basically, it doesn't even have any slice annotation built into this right now. But one thing that is associated with the slice is its namespace. So this namespace is already associated with this slice. So when we deploy the iPerf app, because it's already associated with the iPerf, it will automatically onboard it onto the slice. Right. So if you go, so one other thing here is also when we deploy the iPerf server, we also export a service associated with that, right? So that would be like an iPerf server on the slice convoy, and this is like the port 5201. This iPerf server port is 5201, and it is a TCP. It's not even HTTP, right? So we will deploy the iPerf. Looks like something went wrong with my application. Okay, so iPerf 1 client sleep is running. The server, for some reason, is not running. So let's do what we can do. iPerf is not created. Yes, Leon. So somewhere I saw the namespace is not created actually.
I think it looks like you did not switch the context, so it was trying to put it in the same context, so that's why it didn't create the namespace.
So yeah, this is not going to work now because the context is not there. So let me see here. Where was the? Well, we can do people right away. Okay, so that should work. Okay, so let me just go ahead and do that manually. Make sure that I'm on the right one. So it's coming up. Yeah. So this didn't work, but we'll go back and then do that in a minute. So it's running. So we can do the look at service exports. So if you see, there is an export from this from this cluster. So if you look at the it is exported as like So if you look at the spec, it is a So basically, it is a TCP service with the port and then the name and then the associated DNS name, right? So let's go to the other side. Okay, so you do see, actually, I need to speak it first. We do have the IP server imported on this side, and if you look at it, if you describe them, I think maybe there may be okay. That's just one IP. So this IP server service, right? So it's imported on the other cluster, and then if we go back now to here, and if we do the same thing again,
You have to put the pod name. kubectl exact minus IT pod name minus C iperf pod name. You need to get the pod name.
on,
yeah, copy that, and then insert it after IT. After IT.
Here, I think that's the container. Oh, sorry, IT. Yeah, sorry, here.
Yeah, there. There we go.
So what we have shown here is we have an hyperf slice, convoy slice with a hyperf application deployed, server on worker 2, and the clients on the worker 1, and then an hyperf connectivity across the clusters. So that will come to, where are we on the, so that is up to here. So we did the 6th step right now. We deployed the hyperf and the slice, client and server, and then the service export and import. And then one other thing I want to just highlight the service export and imports. Like they do have the NSNIP. So this traffic was going on the overlay network between the two clusters, right? So the next step, I think we have another 5-10 minutes here. We can quickly deploy the bookinfo application. So this is a standard Istio application, but in this case, we are going to deploy this without Istio, right? So you can always add in the Istio and then
let's Prabhu, let's understand if people are following. Any questions so far? Prabhu can describe each pod, what's happening, each cluster, what's happening. Do you have any unknown answer questions before we go on to the Istio? I know Tanisha and Anurag were trying to do something on Istio, but I just wanted to make sure we have a clear understanding. Going once, Going twice. All right, Prabhu.
Okay, so moving on to the next part, which is deploying a HTTP application across the slice, right? So again, we are using the product page here, but right now on this kind deployment, we're keeping it simple, no STO. So we'll do another demo with the multi-cloud, with the STO, with the MTLS across the clusters. But in this case, we'll keep it simple without any STO, product page on the cluster 1, and then all the other services on the cluster 2. And we have the services exported from the cluster 2 to worker 2 cluster to worker 1 cluster and have it accessible through a browser, right? So again, so book.info, it's like a start book.info. Hopefully I don't run into any issues with that. So again, the product page is like a standard product page. Like as you can see, we have already created the book.info namespace in each cluster. So that should be like this particular service will be automatically onboarded onto the slice. And one thing I would want to point out here is only change we did. In fact, I should say that, in addition to making the this one deployed with the namespace product page, one of the other one is how do they access the reviews and the details, right? So the reviews and details are like an access for the slice. So if you look at this, this has a DNS reviews name, which includes the slice local instead of the cluster local. It will be slice local. So basically, we are telling this product page to access the reviews across the slice, wherever the review services are. It can be in one cluster or multiple clusters. So it will be accessed using that, right? So what about the product page is deployed, and then we can go here, PTX. So product page is deployed. Then we are just waiting for it to get ready. Okay, so the product page is running. So we go to the worker 2 to deploy the all the services, right? So the rest of the services. So the details, as I said, details, it's the stock details, just association with the namespace. So we'll deploy all the 3 of them, ratings. So we'll just wait for them to get ready. It's opening up. So, people who are familiar with the book.info, basically it is one page, single page app with a little bit of content details and the reviews and the ratings. So we'll just go see. So one thing I want to highlight this is we're showing a lot of this east-west and then not showing so much in the north-south. You can literally have a number of different options to increase the traffic into the product page. One option we are using today is the notebook. It is a simple notebook service, and the browser can use this. Using the port forward, we will connect to the product page. But in a real deployment, there can be a number of different ingress options are available to ingress traffic onto the slice. So, yeah, service exports are deployed from the worker 2. Then we'll look at the that correct, Prasad?
Sorry, I was just answering some questions. Sir, what did you say, sir?
And service export, right? Or service exports?
Sir, get service export on.
Yeah, let me just get my connection.
I'm just answering some questions in the. Think of it as.
Yeah, so at this point, we have the service export and imports are available. So let me just go show that here.
So, why don't I, rather than
So
while you're doing it,
service
there are
import.
a bunch of questions in the.
Yeah,
So what
at the end of it, I think I'm just gonna open up a browser. This is port forwarded. So just go to a browser and open up the product page. So we see the product page. So these are the details, reviews, and the ratings. The product pages, as I said, was all from the Okay, so that's the number here.
Thank you. We have 3 minutes. Can you put up the slide which you have, the architecture slide? One more up. Right, guys. I think there are a bunch of questions. So Tanisha and Sudeep and others, right? Leon. So if you can see, there is a distinction between a fleet in Anthos versus this. So think about it. A worker cluster is a cluster which has hundreds and hundreds of nodes, right? And a namespace is actually a construct which you can put a bunch of pods, group them together into a namespace. And the namespace is on any node, as long as you don't have an affinity defined. That is basic Kubernetes at this point, right? Nothing Avisha or KubeSlice is doing it. So if you have how is namespaces used? People use namespaces to group certain set of applications, either team or certain applications, right? Front-end applications are all in one namespace, back-end applications are all in one namespace, and DB applications are all in another namespace. You don't want to have front-end application directly talking to the DB applications, right? Backend application talks to DB applications. So how do you associate isolation? So that's the reason why you create them in a namespaces. Now, let's say a team has a front-end app, backend app, and a DB app, and they want to be different than analytics team, right? Which is also deploying on the same cluster. You can group the 3 namespaces from the team which is doing the front-end app into a slice. The analytics team, which have different namespaces, can also be defined into a slice. Now, there are primitives to isolation, right? As in the front-end app team, which is a green slice, let's say in this example, and the analytics team is a yellow slice, which is in the back. And there are different set of people who need to access that. And there is also a requirement saying that the analytics team should not be conversing to the front-end team, right? So how do you isolate it? So those are all the foundational elements of a slice. Am I clear on that one? Tanisha, Leon, Sudeep.
Yeah.
Got it. Anyway, thank you I think we're up the time.
Thanks, everyone. Thank you. Yeah, thanks for being here.
Thank you, Prabhu, and thank you, Prasad, for all the great. I mean, your troubleshooting skills are great, and I'm glad that the live demo gods didn't actually manage to ruin the show. So thank you for that very enlightening session, and thank you, Prasad, for your ace troubleshooting and amazing knowledge of everything in general. Yeah, so that's it, and thank you everyone for attending, and we shall see you in another fortnight then. So have a good day, wherever you all are, and we'll see you soon. Bye bye.
Thanks,
Bye-bye.
everyone. Thank you.